Okay, so in this video, I want to derive the length of a curve in a bit differently. So let's say that C is a curve C is a curve in the 3 space. It is parameterized by the vector function out of t, where t is between a and b. Now the components of out of t are x of t, y of t, and z of t. And recall that if I take the derivative of r prime of t, it's going to be equal to the vector x prime of t, comma y prime of t, comma z prime of t. And r prime of t is the, if I think of r of t as the position of a moving bug on the curve, then r prime of t would be its velocity. And if I take the length of r prime of t, then the length of r prime of t is the speed of the bug at time t. So I claim that the length of the curve, which in this case would be the distance traveled by the bug from over the period from A to B, and that distance can be found by integrating the speed function from A to B. And notice that the speed function, the length of r prime of t, is equal to the square root of x prime of t squared plus y prime of t squared plus z prime of t squared. So you can recall from the previous video that this is the formula for the length that we obtained. Now let me recall why integrating the speed function from A to B gives us the distance traveled from A to B. To see that, let's say that nu of t is the speed at time t, where t is between A and B. Then to find distance traveled from A to B, let's do the following. We divide the interval from A to B into n subintervals or n subperiods. And let's say n is big, so each of these subperiods are tiny. So let's pick one of these subperiods. So let's focus on one of the subperiods. Now, since the subperiod is tiny, we can assume that even though speed may be a variable function, speed may not be a constant function, but if the period is tiny, then we can assume that the speed is almost constant over this period. And so we can say that, okay, over this tiny period, if I pick a time ti star in this period, then the speed at this time is the average speed over this tiny period. So nu of ti star is the average speed over this tiny period. Again, we are assuming that because this period is tiny, and if I multiply that by the length of this period, let's say the length of this period is delta ti, then if I multiply nu of ti star times delta ti, that's going to be rate times time. That's the distance covered over this sub period. So if we sum over all these sub periods, then we get this Riemann sum, and then as n goes to infinity, we know that this Riemann sum is going to be the integral from A to B of nu of t dt. So we see that if we integrate the speed function from A to B, then we get the distance traveled over the period from A to B. Okay, so this is it on finding a formula for the length of a curve, and I will see you in the next video.